project-based learning submission for the big data analytics subject. Our group consists of three members, myself, Chahat Pariyar, my friend Drishan Dave, and Samrat Ved. Our project focuses on the recent outbreak of GBS syndrome, especially in Pune. We use data visualization and analysis technique to explore patterns, distributions, and possible insights related to the medical condition. The dataset we used here is titled as GBS Pune dataset.csv, in which we contribute 225 people as a sample dataset. It contains various attributes such as age, gender, area of residence, onset data of the disease, and recovery status. The goal was to analyze this data and present meaningful visual insight that could help identify trends and possible area of concern. For this project, we use Python as our programming language, and the main libraries are Pandas for data handling and matplotlib.pyplot and Seaborn for the data visualization. Let me now walk you through the code and visualization. We start by imposing the necessary libraries like import panda as pd, import matplotlib.pyplot, import Seaborn as SNS. Then we load the dataset, our GBS Pune dataset dot CSV. Now, first, by this code, we are going to generate different type of graphs, which can conclude the analysis of this GBS outbreak in Pune. So now we are going to perform that. Just wait for some minute. Okay, now you can see that the graphs are generated. Now there are various types of graphs here. First is area-wise distribution. So as you can see here, in this section of the code, we plot the area-wise distribution of GBS cases. This bar chart shows which area in Pune reported the most GBS cases. It helps us identify hotspots where the disease was most prevalent. Now the second is gender-wise distribution. Okay. Now, this pie chart shows what percentage of the total cases were male versus female. It provides insights into whether one gender was more affected than the other. Now, the third is age distribution graph. This histogram helps us understand which age group were more vulnerable. We use a KDE curve to visualize the density of cases across different age groups. Now, the fourth graph will be recovery status analysis. This graph categorizes the outcome into three groups: recovered, hospitalized, and deceased. It gives us a clear picture of how severe the outbreak was. And the last but not the least, the graph is onset trend over time. This line graph shows how the number of daily cases fluctuated over the months. It helps in identifying the peak period of outbreak. Now, from now, my friend Drishan will continue and
So hello guys, I am Drishan Dave. So I will now carry on from here. So we've also made an web application that predicts GBS based on patient information like age, gender, area, and the month their symptoms started. So let me show you the code. This is our code. Let me first show you the data set we have used. So here's the data set of almost 250 patients. So yes, so yes, let's come back to our app. So yes, in this app we have included all the major libraries like Pandas, Streamlit, and yes. In this line of in this block of code, we are preparing our data set like hospitalized, onset month, age, gender, area, and then we will, uh, yes. So in this column of block, some columns like gender and areas are categorized categorical. So we use a column transformer to apply one hot encoding only to the those columns while leaving numerical features like age untouched. And so in this block of code, we now comes the machine learn it there now comes our machine learning model. We use the logistic regression classifier and wrap it with the pre-processing steps into a single pipeline. This ensures consistently during training and prediction. So in this block of our code, we split the data into training and test sets and fits the model pipeline on the training data. So, and in the next block of code, that in this block, we uh, it's time for now for the cool part, the front end. We use Streamlit to create a super simple and interactive web interface that that includes number input for age, drop downs for genders and area, a slider for the month of onset. So in the next block of code, when the user clicks the predict risk button, we collect the input into a data frame and use our model to get the risk probability. Finally, we multiply it by 100 and display it for percentage. So let me show you the output of our model. So here is our web application. So it says GVS risk prediction web application. So in this, we have to enter our age. We have included the plus and minus to enter our age. Like we can also enter from here, or else we can just directly type in. So my age is 22 years. So then we have to select our gender. So we have a drop down menu, male or female. So I'm selecting male, and we can select the area where we live in Pune. We have entered limited areas because the data set was small. So let's select our area as go through, and we have to select the month in which the in which our symptoms was started. So one represents January and 12 represents December. So like my symptoms were started in fourth month. So I will set it to 4 and then I will click the button predict risk. So here's the output. The output is predicted GBS risk is 20%. Uh, so let me change the month. So let's say I've changed the month to September, that is 9, and now I will again predict the risk. So in September, the risk is 65% as the symptoms are stronger in September. Yeah. So thank you guys. That was our model. Stay safe, drink clean water, and do not let GBS happen to you. Signing off.
Stay